In this video, we are going to study in detail the E5 error code in air conditioning units manufactured by Samsung, analyzing not only its technical meaning, but also the possible causes and diagnostic methods that allow a deeper understanding of the origin of this type of fault. This code is one of the most common that can appear in the indoor unit of Samsung systems, both in domestic units and in commercial or inverter systems, and its correct interpretation is essential to avoid unnecessary component replacements and to achieve efficient repair. Let's start by saying that in most Samsung models, both inverter and non-inverter, the E5 code is closely related to problems detected in the well sensor, also called the pipe sensor or refrigerant temperature sensor in the indoor unit. This type of sensor performs an essential function within the system, as it informs the electronic control board about the real temperature of the indoor coil, allowing the microcontroller to adjust the operation of the compressor and the fan to maintain stable and efficient performance. The main function of this sensor is to measure the refrigerant temperature inside the indoor coil's piping in order to prevent the temperature from dropping below 0 degrees Celsius, 32 degrees Fahrenheit, since at that point, frost or ice could form on the coil, which would affect heat exchange and significantly reduce the cooling capacity of the unit. It is important to mention that, basically, there are three types of faults that can occur in this sensor: open well sensor, short-circuited well sensor, uncalibrated well sensor. In most cases, the control strategy of the electronic board activates the E5 error code when one of the first two faults occurs, since these generate a reading outside the normal resistance range and can be easily identified by the self-diagnostic system. Open well sensor. This failure occurs when the stimulus current sent by the electronic board to the sensor cannot return or close the circuit due to interrupted wiring, an internally open sensor, or simply a connector that has come loose or has poor contact. In this case, the circuit behaves as if the sensor did not exist, causing the temperature reading to completely disappear for the board. This type of fault can be diagnosed using a multimeter set to the kilo ohms range. The reading should show infinity, indicating an open circuit. Short-circuited well sensor. This failure occurs when the verification current sent by the board to the sensor returns with the same voltage without passing through the resistive element of the sensor. This can be caused by wires touching each other, connector issues, or an internally damaged sensor that has lost insulation. When measured with a multimeter on the resistance scale, kilo ohms, the reading will show 0 ohms, confirming a short circuit and the sensor's inability to send a valid signal to the control board. Uncalibrated well sensor. Depending on the degree of miscalibration and the control strategy implemented in the equipment software, some electronic boards can detect this type of fault. However, in most cases, it is easier for the system to identify an open or short-circuited sensor than a slightly uncalibrated one, since the measured resistance may still fall within an acceptable range even if it is inaccurate. This can cause incorrect temperature readings, resulting in intermittent failures or poor performance without necessarily displaying an error code. General operation of the sensor. Well sensors have a variable electrical resistance determined by temperature. This resistance can be measured by the control board, which sends a small reference current through the sensor. Using a voltage divider, the controller interprets the variation in the return voltage and thus determines the temperature being measured by the sensor. For example, at low temperatures below 0 degrees Celsius, 32 degrees Fahrenheit, the resistance increases, while at high temperatures above 25 degrees Celsius, 77 degrees Fahrenheit, it decreases. The type of well sensor used in Samsung equipment is an NTC type, negative temperature coefficient, which means its resistance decreases as temperature increases. It is essential to consult the service manual for the specific resistance value of the sensor corresponding to the model. However, for most Samsung models, at a temperature of 25 degrees Celsius, 32 degrees Fahrenheit, the resistance is usually 5 kilo ohms in some units and 10 kilo ohms in others. These variations depend on the design of the reading circuit and the thermal range expected by the control board. How to fix the E5 error in Samsung air conditioners. A. Turn off and unplug the unit for at least 15 minutes to allow the board to fully reset and the internal capacitors to discharge. B. Plug in and turn on the unit again and check if the error reappears. In some cases, a simple power reset can restore the sensor reading. C. If the error persists, turn off and unplug the unit again. Check the cleanliness of the indoor coil and air filter. Dust accumulation can affect thermal readings and cause false activation of the code. While the indoor unit is open, verify the correct position of the well sensor, which must be firmly attached to the coil pipe using a clamp or metal clip, ensuring good thermal contact. Also check the condition of electrical connections and wiring. E. Plug in and turn on the unit again to check if the E5 error reappears after a few minutes of operation. If the error continues, turn off and unplug the unit again. Visually inspect the electronic board, look for signs of damage, moisture, or corrosion, and disconnect the well sensor from its connector. G. Using a digital multimeter, measure the sensor's resistance on the kilo-ohm scale. If the reading is 0 ohms, the sensor is short-circuited. H. If the reading shows infinity, the sensor is open and must be replaced. I. Using the equipment service manual and the sensor's resistance chart, verify whether the measured value matches the ambient temperature. For example, if it is 25 degrees Celsius, the value should be approximately 5 kilo ohms or 10 kilo ohms, depending on the type of sensor. J. If you don't have the manual's chart, touch the sensor with your hand. Doing so will increase the temperature and the resistance in kilo ohms should decrease, confirming that the sensor responds correctly to thermal changes.